Assalamu alaikum wa rahmatullahi wa barakatuh. Dear student of first secondary, we are going to solve questions of Egyptian Knowledge Bank. We will start with a group of questions for Unit 4 Thermochemistry, and we will have different questions and we will solve these questions for Nagwa platform. Okay, let's start. The first question today we have: the change in energy during chemical reaction may be explained by or explained in terms of electrostatic interaction between subatomic particles. Which of the following best describe the change in energy when covalent bond is formed? Okay, we have different, we want to make a bond. Okay, if I want to make anything, you must have energy. Okay, but sometimes you need energy get out or convert from one form to another. This is a kind of energy as well, and we release or get out energy due to the reactions between kind of charges that we have inside the atom. Okay, when we have a kind of reaction like reaction between positive ion or protons and negative ion like electrons, now we make a bond for opposite charge. Okay, we need to make bond, so we need energy or release energy. Okay, let's discuss our choices today. Bond formation absorb energy due to increased electrostatic attraction between protons and electrons. Bond formation releases energy due to increased electrostatic attraction between protons. Bond formation releases energy due to increased electrostatic attraction between protons and electrons. Bond formation releases energy due to increased electrostatic repulsion between protons. Okay, we need repulsion when we make the same charges. Okay, the last one here we have bond formation absorbs energy due to increased electrostatic repulsion between protons and electrons. Okay, what we want to form, we want to make electrostatic attraction between subatomic particles. So we need to get what? We need to bond formation. Okay, I want to make a bond formation, releases energy. Okay, when we make a bond, we get energy outside the reaction due to increased electrostatic attraction between protons and electrons. When this kind of force increase, so we release energy. Okay, also what happen when we make to break a bond? To break a bond, we what? No, we take an energy to break a bond. So when we form a bond, we release energy. When we break down bond, we want or take energy. Okay, let's going to question 2. Question 2 says that the decomposition of calcium nitrate proceed according to the following equation. We have here an equation that illustrate the decomposition. We have calcium nitrate, its chemical formula calcium CaNO3 by 2. It is in the solid form. Okay, we take 2 moles that will decompose into calcium oxide, 2 moles also, and 4 moles of nitrogen dioxide, and oxygen gas evolves at the end of reaction. Also heat comes out, plus H equal 369 kilojoule. Or we can get in the other side, we can write delta H in the other side, but we will reverse the sign. Okay, how much energy is needed to decompose 3.2 moles of calcium nitrate? Give your answer as a whole number. Okay, what happened here? At first we have a problem, we need to mention the steps that we will do. At first we have in this equation, we have 2 moles of calcium nitrate give this amount of delta H or heat content. So 2 moles of calcium nitrate gives 369 joule or kilojoule. Okay, after that we want what? We want to know what happened in case of 3.2 moles. Okay, we want to know 3.2 moles. We will make cross multiplication just, okay, so x equal 369 times 3.2 divided 2, okay, so the right answer will be 590 kilojoule. Okay, the right answer will be 590 kilojoule. Okay, this is the first problem. I think it's simple. We have different questions. Let's going to question 3. Okay, question 3 says that the chemical equation for the decomposition of magnesium carbonate is as follows. We have here a different, we have 2 moles also of magnesium carbonate MgCO3 as a solid state. It will give magnesium oxide solid, carbon monoxide as a gas, plus delta H 117 kilojoule. Okay, based on this equation, which of the following statement is true? We have here different answers, and we will want to choose the best for this equation. Okay, we have here the first one, 117 kilojoule of energy is released when a single molecule of MgCO3 decomposes. Okay, when we have a single molecule of MgCO3, we have a what single molecule? No, we have 2 moles of MgCO3. The other choice, 117 kilojoule of energy is needed to make 1 mole of MgCO3 decompose. Okay, I think it's right. Okay, we will complete till we reaches. If we have another one, will be right. We have 117 kilojoule of energy is needed to make 42 gram of MgCO3 decompose. 117 of energy is needed to make a single molecule. It is a single molecule of MgCO3 decompose. Here we have 117 kilojoule of energy is released when 1 mole of MgCO3 decompose. Okay, there is no one here. We have 117 energy released when 1 mole, okay, of MgCO3 decomposes. Okay, as we say, when we break a bond, okay, we needed energy. No, we released the energy. So we have here, this is 1 in B is wrong. Okay, so the right answer will be right or wrong. Okay, we have here 2 choices. Maybe will be sometimes will make a conflict for us. We have 117 released when 1 mole. Okay, I said when we write the delta H or heat content at the end of reaction, this needs that it's a product here. So when we want to get or to write this one, delta H at the other side, okay, we will have here the other side to make this one available, that we will have 117 kilojoule of energy needed to make 1 mole of MgCO3 decompose. Okay, why? As we have here 1 mole product of MgO, magnesium oxide, will be product MgO. Why we choose this one? Okay, we can choose 2 moles of magnesium carbonate, but here we have 1 mole of magnesium oxide will be the product. So we make a broken for 1 mole only of magnesium carbonate. This is the answer why we choose this one. We have 1 mole of magnesium carbonate decomposed, so this amount of energy give 1 mole of magnesium oxide, as we didn't make complete decomposition. We have also less than it. We have also another mole, but this energy needed to make 1 mole of MgCO3. We take this energy, depend on the product we take out. We have MgO that depends on our product that we take. What we take 117 to make 1 mole of MgCO3 to make decomposition. Okay, let's going to question 4. We have question 4 says that what name and symbol are given to overall change in energy at constant pressure during a chemical reaction. Okay, we have potential difference delta H, temperature change delta H, enthalpy change delta H, entropy change delta H, and activation energy H. Okay, what we have to express, all over the reaction changes in the heat energy, we can say that we make enthalpy change delta H. We make enthalpy change delta H. Okay, I think it's easy question. Let's go to question 5. Okay, we have question 5 says that which of these statements doesn't describe the conservation of energy in a chemical reaction? Okay, we have all of these can express conservation of energy rule or law, but we have one of them not express the conservation. We have the wrong one. We want the wrong one. Energy is neither created nor destroyed during a chemical reaction. Yes, it's right about the conservation of energy. The energy contained in the bond of reactant molecules always equal the energy contained in the bonds of product molecules. If the energy of system increases, then the energy of surrounding decreases by exact same amount. Energy can only be transferred from one form to another. If the energy of a system decreases, then the energy of surrounding increases by exact same amount. Do you think which one will be wrong? Okay, we have here the right answer will be choice B. The energy contained in bond reactant molecules always equal, no, not equal as all, not equal the energy contained in bond of the product. Okay, we said that we want, if we want to make a bond breaking, we add energy to the reaction. Okay, but if we make a bond, we will have an energy released at the end of the reaction. So which one not describe or can make a conservation of energy? Heat or energy in the bond of molecules of reactant not equal, but here we have equal. No, it's not equal. So this is the wrong one about the energy. Let's go to question 6. We have question 6 says that why do chemical reactions usually involve a change in energy? Okay, what we conclude from our studying the process of making or breaking bond during a chemical reaction absorbs and release energy. Okay, this is the first one. Second one, the process of splitting the nucleus of an atom releases large amount of energy. We can't make a splitting of the nucleus as whole, as it is the dense part of the atom. Third one here, in chemical reactions atoms are destroyed and converted into energy. Okay, maybe sometimes we can make a destroy two atom as whole. No, sometimes we can break a molecule, not an atom. Okay, the nuclei move faster during reactions and so require more energy. Okay, what do you think will be happen in the chemical reaction? I think the first one will be the right. We have the process of making or breaking bond during a chemical reaction absorb and releases energy. I said we are talking about the bond inside the molecules. We have a kinds of bond that we want to break. We can't break down nucleus. We can't break down atoms as whole. We can't break down the nucleus or atoms, destroying and convert to energy or any of them. But we can make or break down and forming a bond that will depend on the kind of reaction if we want to make a bond formation or bond breaking. Okay, this is the right answer. Let's go to the question 7. Which of the following is not type of energy that a chemical reaction may produce? We have light, electric, color, heat, and chemical. We want to know not a type of energy. We have a light energy, we have an electric energy, we have an heat energy, we have a chemical energy, but the wrong one will be color. It's not an energy as well. Okay, let's go to question 8. Question 8 says that the reaction of calcium oxide Okay, with water, calcium produces calcium hydroxide and releases 57.3 kilojoule of energy. How much energy is released when 10 gram of calcium oxide is reacts with excess of water? Give your answer to 1 decimal place. Okay, we have here the atomic masses of calcium oxide, of calcium Ca40, hydrogen H1, oxygen 16. Okay, we will discuss at first the equation. We have the equation says that calcium oxide plus water, in the presence of water, we said the reaction of calcium oxide, this is the formula, plus water will give calcium hydroxide CaOH by 2 and releases plus delta H. We can write plus delta H, or releases we add negative sign, negative 57.3 kilojoule per mole. Okay, how much energy released when 10 gram of calcium oxide is reacted with excess water? Okay, we have here calcium oxide, we have 10 gram. So at first we will make what? We will calculate the molar mass of calcium oxide. So we have calcium oxide and calcium hydroxide as product. We wanted to get the amount of calcium oxide. We have molar mass of calcium oxide, 40 plus 16 will give 56 at first. So number of moles equal mass over molar mass. We will have here the mass 10 grams divided molar mass 56, so the number of moles that we have here in our condition will be 0.178 mole. Okay, and in this case we will not make approximation to any product. If we have decimal numbers, we will make approximation at the end of reaction. Okay, at the end of product only, not we can add it or change it in any case. Okay, so we have 1 mole of calcium oxide give what? Give 57.3 kilojoule. Okay, after that we have 0.178 mole of calcium oxide give what? Okay, we want to get the number of moles this to give what energy released. So we will make a cross multiplication. We have x here equal 57.3 kilojoule times 107 times 0.178 divided 1. Okay, we will have this one, we will get 10.2. okay, at the end of reaction we will have 10.2 kilojoule that releases at the end of reaction when decompose this amount of what? Of calcium oxide. Okay, when we have 10 grams, so we releases energy of 10.2 kilojoule. Okay, let's going to question 9. We have question 9 says that the value of delta H when liquid water freezes to solid water. Okay, we have here, we want to change from liquid state to solid state. We want to release, or we want to change from a physical state that have a less energy to a solid state as a high energy needed to make it, so it releases energy as negative 6.01 kilojoule per mole. What is the value of delta H when solid water melts to water liquid? Okay, or liquid water. So if we want to get azole, we want to convert from liquid to solid, we have value delta H equal negative 6.01 kilojoule. If we want to reverse the reaction or convert from solid water here to liquid water, so we will reverse the same amount of delta H, okay, or heat content. So we have delta H of water liquid to solid negative 6.01 kilojoule per mole, and delta H of water from solid to liquid will be reversed but not anything else, so we will have plus 6.01 kilojoule per mole. This is the right answer and simple for this question. We have the last question here. Fuels can be used also to provide energy. Which of the following fuels doesn't proceed energy through a chemical reaction? Okay, we want to know what is the fuels that not produce energy through a chemical reaction, not depending on a chemical reaction. We have biofuels, okay, that is dependent on the dead bodies. Fuel cells, okay, it will also depend on the presence of fuel, as it will make a chemical reaction, so it will produce an energy. Nuclear fuel, do you think it will make a chemical reaction? Okay, let's release it at the end. Okay, fossil fuel, okay, it also depends on a chemical reaction, and it will make a long time for forming a fuel, so it will also depend on the chemical reaction. Batteries, it will convert a chemical reaction into electric energy, so the right answer will be what? The right answer will be nuclear fuel. Nuclear fuel, it is the one that of the fuel that doesn't produce energy through a chemical reaction. Why? As it depends on the presence of high number of neutrons and big number of protons. Neutrons and the protons make a large or huge nucleus for the element, so the element will be radioactive element, and we can use it as a nuclear fuel. So it depends on the kind of element that we use. So it's a kind of fuels that not produced due to a chemical reaction. Okay, it present inside the nucleus of some kinds of elements, so we called it nuclear fuel. We called it what? Nuclear fuel. It depends on the mass and the kind of metals or elements that we use. Okay, this is the last question of our group today. I hope you enjoy this part of questions. This is the first part that we will discuss in Egyptian Knowledge Bank. We will have different choices and we want to solve them together. If you have any questions, please leave them below the video or any way of communication that we have taken. Okay, thank you and goodbye.